goal of this series of learning modules is to educate you, the mason, in identifying areas that require flashing, the types of flashing typically used for masonry construction, and general guidelines for proper flashing installation. We are focusing on best practices as well as code-based requirements. If your project specifications vary significantly from the topics discussed in this video, you should bring it to your supervisor's attention. Although this module will focus on cavity wall and veneer flashing, it is not a how-to video. This is part 2 of 3 videos on masonry flashing. The technical content of flashing for masonry is based on building code requirements and specification for masonry structures, or TMS 402 and 602, and International Building Code, or IBC. When we refer to the code in this training module, we are referencing these documents. In the first module of flashing for masonry, we identified the types of flashing used in masonry, flashing accessories, and locations in which flashing is required on exterior masonry walls. Part 2 will focus on flashing of cavity and masonry veneer walls, with a more in-depth look at their installation requirements. Cavity and veneer walls contain a continuous airspace between an inner width of concrete masonry units or other backup system that are tied to an exterior width of brick or other architectural masonry units. For simplicity's sake, both of these walls will be referred to as cavity walls for the balance of this module. Insulation may be incorporated into the cavity of these assemblies. Flashing functions as a critical component of the overall cavity system. Areas that are critical for flashing installation include at the wall base, shelf angles, openings, and copings. The code does refer to other areas, such as chimneys, porches, decks, balconies, and built-in gutters. In all of these cases, the installation would still fall under the guidelines of this video, if treated as a wall base, coping, or opening. Let's start with general requirements at the masonry wall base. Shelf angles and intermediate roofs will require a very similar installation type in regards to the flashing, so we'll include them in this first discussion. In all 3 cases, the flashing and weepholes are functioning to direct moisture out of the cavity wall through the base of the wall or horizontal obstruction. Shelf angles and intermediate roof locations will likely have additional requirements for installation to accommodate wall movement or tie into roof assemblies. According to code, flashing and weepholes in anchored veneer shall be located in the first course of masonry above finished ground level, above the foundation wall or slab. Flashing and weeps located below finished grade will be totally ineffective. Also, when brick comes in contact with the soil, capillary action draws moisture and salts from the ground into the wall, resulting in efflorescence. The base flashing provides a barrier to the above-grade masonry to prevent capillary action from damaging the exterior wall. Flashing should be longitudinally continuous or terminated with end dams. Continuous requires that the joints be overlapped sufficiently, 6 inches minimum, to prevent moisture from entering between the joints. They must be bonded together with adhesive if they are not self-adhering, to prevent water movement through the lap area. Lap splicing of metal flashings is not recommended. Typically, specifications require soldered joints for metal flashing. In cases where splicing is allowed, splice metal flashing with a 1/4 inch gap joined and sealed with a pliable membrane to help accommodate expansion. Flexible flashing should be supported over the airspace, gaps, or open cores to ensure moisture can drain through the weepholes and the flashing remains undamaged. Sagging flashing will trap moisture rather than drain it. Moisture can freeze and cause splits in the membrane, leading to leakage. Further, frozen moisture within the cavity can affect unit durability due to freeze-thaw activity. Ideally, flashing should be secured adhesively with a termination bar and sealed so that water cannot infiltrate or move behind the attachment. The flashing should project downward along the outer surface of the inner width and then project outward at the masonry bed joint, shelf angle, or lintel to discharge moisture. Every effort should be made to slope the flashing towards the exterior. Effectively placed mortar or sealant material can help promote this drainage. The flashing should continue beyond the exterior face of the masonry a minimum of 1/4 inch and terminate with a sloped drip edge. UV sensitive flashing should not be exposed to sun or ultraviolet rays. In that case, the use of a pre-manufactured drip edge, sealed to the substrate, is required. Excessively sharp edges at corners and protrusions should be avoided. When flexible or composite flashing is installed over a metal drip edge, the flashing is typically held back 1/2 to 3/4 inch from the face of masonry. The flashing should lap the drip edge by a minimum of 1 inch and be sealed to the drip edge with the manufacturer's approved adhesive or sealant. Continuity at corners and returns is achieved by cutting and folding straight sections of flashing or using a preformed flashing corner. Preformed corners should be placed under the flashing and sealed with the manufacturer's recommended sealant. Discontinuous flashing at jambs, control or expansion joints, and at any place the masonry meets a dissimilar material such as curtain walls, should terminate with an end dam in an end joint, rising at least 4 inches. Place weep holes at the spacing indicated and ensure that they are prevented from clogging. Code requires that designers use a maximum spacing for weep holes of 33 inches on center. Designers will likely require a spacing of less than 33 inches, and masonry material will dictate the spacing due to the variety of masonry units. If the specification dictates a weep hole spacing less than the individual unit length, it is important to clarify this with the designer before installation. The designer has a variety of options for weeps, natural and synthetic. Efforts should be made to prevent insect infiltration, but if sash cord is used, ensure that it is made of cotton and not synthetic materials. Install mortar control devices in the airspace if indicated. The flashing should always extend several inches above the mortar control device. Ensure that mortar droppings are minimized during construction. The use of devices such as wooden sticks can be used to remove droppings from the cavity and can ensure weep holes remain unobstructed and allow moisture to exit the wall. If allowed by specifications, temporary access openings at the base of the wall can allow for the daily removal of fresh mortar droppings. Care should be taken to ensure the flashing is not damaged when removing droppings. When installing flashing at intermediate roof or wall transitions, ensure the flashing and weep hole are installed directly above the roof reglet or tie-in. Review the roof details prior to installation. Coordination with the roofing contractor is highly recommended. Relieving angles should be treated in a similar fashion to wall base flashing, but always as detailed by the architect. Although not a focus on flashing, as a general rule, great care must be taken to ensure mortar does not come in contact with the veneer below the angle, and the compressible filler is installed as detailed. Some designers will include a weep hole vent at the top of the wall panel to ventilate and dry it. Flashing must be placed without punctures or tears. Openings created for reinforcement, anchors, or connectors must be closed with a compatible sealant. Protection may be needed around bolts fastening shelf angles to the structure. Since any opening in a wall is an opportunity for a leak, moisture protection at openings is critical. Let's take a closer look at flashing above and below exterior masonry wall openings. Flashing above wall openings follows a similar process to wall base flashing, with the flashing extending longitudinally the width of the lintel. End dams, either field formed or prefabricated, should be installed under the flashing and sealed at each end of the lintel. The drip edge is sealed to the lintel the width of the opening. Lap and seal the flashing to the drip edge in a manner previously discussed. A preferred method is to adhere the flashing to the backup width with a termination bar and seal at the top of the termination bar. Ideally on lintels, the masonry units are laid directly on the flashing without bed joint mortar. Weeps are laid flat on the lintel. The lintel should be level and not angled back in a fashion that would allow water to pool below the weep hole and not drain. Ensure the weep holes are not obstructed by mortar, sealant, or other materials to ensure proper drainage. The joint between the lintel and the bearing at the jamb should be sealed to prevent moisture from migrating back below the lintel. In most cases, this space will also serve as part of a control or expansion joint. The placement of flashing below openings is similar, although the units may be laid in a bed of mortar to maintain coursing, and the end dams are placed at the end of the sill material. Ensure that flexible and composite flashings are fully supported at flashing below openings, or angled to the back of the units, as there may be no support of the flashing at the airspace. Support may be part of the design, such as an angle support, or may require a metal flashing piece underneath the flexible flashing to provide support. Flashing at copings of cavity walls. To prevent water from entering the walls, flashing with projecting flanges on both sides must be installed continuously at copings. If there are dowels, as in the case of precast or stone coping, seal the flashing around the dowels to prevent water from leaking into the masonry below. In the case of wood blocking and metal coping, it is best practice for the mason to seal the top of the wall with flexible flashing material, secured with adhesive recommended by the flashing manufacturer, as well as seal around anchor bolts and embeds. This membrane will provide protection to the top of the walls during construction. In particular, it protects the top of the wall, as required by code, prior to the installation of wood blocking and metal coping cap by other trades. The best flashing materials, installed improperly, won't prevent leaky walls. The Upstate New York chapter of Mason Contractors Association of America operates in the spirit that, if it's good for masonry, it's good for us all.